Hey y'all! Welcome to West Texas 3D Printing, tutorials curated by nerds, delivered by your favorite avatar, Lulu. Top layer quality comes from three things: consistent extrusion, solid internal support, and proper cooling. If any of these are off, the top surface will show defects. Let's break down the most common problems and how to fix each one. First, gaps in the top layer. Gaps usually mean the top layers don't have enough support underneath. Increase infill to 15 or 20% and increase the number of top solid layers. For a 0.2 mm layer height, aim for at least 4 or 5 top layers. Use grid or rectilinear infill for stronger support under the top surface. Next, rough or uneven texture. Uneven top layers often come from inconsistent flow. Check for partial clogs, wet filament, or filament grinding in the extruder. Slightly increase top layer flow if the surface looks starved, and slow top layer speed for smoother extrusion. A good top layer speed is around 20 to 30 millimeters per second. Now, shiny patches or dull blotches. Inconsistent shine usually means uneven cooling. Make sure the part cooling fan is working correctly and airflow isn't blocked. If the top looks overly glossy or melted, lower the nozzle temperature by 5 degrees. If layers aren't bonding well, increase temperature slightly instead. Next, visible lines or ridges. Ridges often form when top layers print in the same direction every time. Enable alternating top layer directions to smooth the surface. Slow the top layer speed and make sure the Z-axis moves smoothly without binding or wobble. Now, rippled or wavy top surfaces. This usually means infill is showing through. Increase the number of top layers and increase infill overlap so the top layers bond tightly to the infill. Make sure the infill pattern isn't too wide or too sparse. Next, matte spots or fuzzy texture. This almost always means wet filament. Dry the filament for 4 to 6 hours and check extrusion consistency again. Now, under-extruded top layers. Thin, weak, or broken lines indicate under-extrusion. Check the nozzle for buildup, verify filament tension, and slightly increase flow if needed. Slowing the top layer speed also helps the extruder keep up. Now, over-extruded top layers. Bulging lines or raised edges mean too much material. Reduce flow by 1 to 3%. Check that the nozzle diameter and filament diameter are set correctly in the slicer. Next, cooling problems. If the top surface looks soft or saggy, increase fan speed. For PETG, avoid excessive cooling. Too much fan can cause brittle or rough top layers. Make sure fans are clean and spinning freely. Now, infill interaction. Top layers rely on consistent infill beneath them. If infill is too sparse or misaligned, the top surface will dip or ripple. Increase infill density and use stable patterns like grid or gyroid for even support. Next, vibration. If the printer shakes during top layers, the surface will look uneven. Lower acceleration, tighten belts, and ensure the printer sits on a stable surface. Now, a quick checklist for perfect top layers. Enough top layers for your layer height. Proper infill density. Consistent flow. Correct cooling. Smooth Z-axis movement. Dry filament. Clean nozzle. Slower top layer speed. Alternating top layer directions. When these elements are balanced, the top surface becomes smooth, solid, and consistent every time. Thanks for watching from all of us at West Texas 3D Printing. Yes, even me, Lulu. Like, subscribe, and keep turning chaos into clarity.